All right, so I'm just starting this first example a little bit out of order. So I'm just starting with this table here in the solution. Okay, so this is information about a journey that a cyclist took. Okay, and after 0 hours, the cyclist had gone 0 kilometers. So this is time in hours. This is distance in kilometers. After 1 hour, they've gone 10 kilometers. After 2 hours, they've gone 20. After 3 hours, they've gone 30. After 4 hours, they've gone 40 kilometers. Okay, so we've got that table. All right. And one thing I could do with a table like that is I could draw a graph based on it, and that's one thing I'm gonna ask you to do as part of the questions you're doing today. Is take a table like this and draw a graph like the graphs we were drawing in coordinate geometry of the line. Okay, so the Cartesian graphs. Okay, the ones with the x and the y axis. Okay, so if you were to draw a graph of this journey, you'll notice that the time is positive. Okay, so you don't need to worry too much about the kind of the minus x's, and obviously the distance is always positive as well. So you know, when we did this in coordinate geometry, we'd have loads of minuses gone out there and loads of minuses gone down here. We don't need to worry too much about that. We're just looking at the positive bit of the graph. Okay, so you'll notice that this graph in hours goes 0, 1, 2, 3, 4. So the way this person has drawn it is every box is 1 hour, but they need to go up in bigger jumps for the kilometers. Okay, so if you're looking at your copy, you probably don't have 40 boxes to go up 40 kilometers. So they've decided to go up in jumps of 5. Okay, you could go up in jumps of 10 as well, all right, but they've decided just to stretch it out a bit to make it easier to read and go up in jumps of 5. Okay, so they've put the 0, 1, 2, 3, 4 hours on the x axis. You're always going to be putting time on the x axis in these, and then you're going to put distance on the y-axis, and that's what you're going to see over and over again in the questions I do and in the questions I give you to do. Okay, and then as I say, distance, they've gone up in jumps of 5. So then 0, 0. Okay, so just be careful, that's where the two lines cross. So this starts at 0 and this one starts at 0 as well. After 1 hour, they've gone 10 kilometers. After 2 hours, they've gone 20 kilometers. After 3 hours, they've gone 30 kilometers. After 4 hours, they've gone 40 kilometers. Okay, so that would have been the steps in making that graph, is putting on the point 0, 0, 110, 220, 330, 440, and then just drawing that line to connect them up. Okay, so as I say, in the questions I'm going to give you to do, you're going to be given this table and then draw this graph from it. Okay. Now, one thing they're going to get you to do, and what links this to what we've been doing so far, is when you have a graph of time and distance, there is a way of getting speed from the graph. Okay, there is also often a way of getting it from the table as well as the kind of the formula that we've just been doing. Okay, so look, if we were asked to get the speed of that cyclist, I could use my formula. So speed is equal to distance over time. Okay, and this person travels 40 kilometers. That's the distance traveled in 4 hours. What's 40 divided by 4? It's 10 kilometers per hour. Okay, so sorry, it's just about, you can just about see that there, I think. Okay, so 10 kilometers an hour is their speed. All right, so that's one way of getting the speed of this cyclist, is just using the formula. Okay, another way, you can see it on the table, because if you look, every 1 hour that passes, they're going another 10 kilometers. So if every 1 hour passes, they go 10 kilometers, that must be 10 kilometers per hour. And you see they've put this column here for change in distance. That's where you see the plus 10 kilometers, plus 10 kilometers, plus 10 kilometers every hour. Traveling 10 kilometers every hour that's what 10 kilometers means. The other way we can get the speed from this from what we've done in this question is if you get the slope of that graph. Okay, so you've drawn a line, and if you remember back to coordinate geometry, if you get rise over run, you get the slope of a line. Okay, and if you get the rise over the run of that line, you are going to get the speed of a cyclist. So if you have a graph of time and distance, the slope of your graph is going to be the speed. Okay, and you see here the 2 points they picked in this example was this one here and this one here. Okay, and between those 2 points, the run is just 1. Okay, so from that point to that point is just 1 box across. Okay, be careful with the rise on these ones. Okay, so often in coordinate geometry line we would have said the rise there is 2 boxes. Okay, so rise over run is 2 over 1, but remember you're going up in jumps of 5 here, so going up 2 boxes is actually a rise of 10. Okay, so it's important that you do your rise and run in terms of what these numbers are, not just counting boxes. Okay, but run of 1, rise of 10, rise over run, 10 over 1, 10 kilometers an hour. So same answer. Okay, so you see kind of 3 ways of getting the speed there. One kind of quite informal way, just getting it from the table like that. Every 1 hour that passes is 10 kilometers traveled. You can get it from your formula, so just take the kind of total distance traveled over total time. 40 over 4 is equal to 10 kilometers an hour, or pick 2 points on your graph and get the slope between those 2 points. And you could pick any 2 points on the graph. What I would say is pick something like, say, this and this. The ones where so if you picked this point here, say after 5 kilometers, it's hard to exactly see maybe how far has traveled. We'd be able to figure it out, but I would say pick like 0, 10, 110 or 220 or 330 or 440, okay, as one of your points for getting the slope. Okay, but there's 3 ways of getting the speed when you're given something like that. All right, so just the last thing to say is you'll notice that every hour that passes they travel 10 kilometers, so their speed is constant. Their speed isn't going up or down. Okay, so when speed goes up or down, the graph will look a little bit different to this. All right, but if it's just a straight line, that means the speed must be constant. The speed doesn't change. Okay, and you can see that by taking the slope at any 2 points. It won't be any different depending on what 2 points you pick. Okay, so we've got a constant speed there because the line is straight. All right, so as I said, I'm going to give you a question to do where you're going to given that information there, the table. You need to draw that graph, and then you'll be getting the speed a couple of different ways. All right, what I just want to do is a couple of examples where we're getting the speed from a graph. All right, so I'm going to do this one here, this question 3, and this one here, this question 4, because I'm going to get you to do a couple like this as well. So in question 3, the graph shows the journey of an object over a period of time. So I'm not really sure what the object is. And you can just about see here that's time in hours. So 1, 2, 3, 4, 5, 6. And the y-axis is distance. And it's going up in jumps of 10 here. Every box is 10. So look, I would say 2 ways of getting the speed there from what they've given us. I could either say that figure out what's the total distance traveled. So by the time you reach the end of that journey, you've traveled how far? 60 kilometers. Okay, so that's your distance. And how long did it take you to travel 60 kilometers? 6 hours. Okay, so this point here means the person has traveled 6 hours and they've gone 60 kilometers. So speed is distance over time. So that's equal to the total distance was 60, the total time was 6. So that is 10 kilometers per hour again. Okay. The other way I could do it then would be to pick 2 points. Okay. So let's say I pick this point here and this point here. Okay, so what's the rise over run between those 2 points? And I can pick any 2 points in the line. Okay, just pick those 2. Okay, so what's the rise over run? So the rise is 1, 2, 3 boxes. Okay, so slope is rise over run. So I said run is 3. And the rise then, so it's 1, 2, 3 boxes, but just be careful, because what's 3 boxes here? It's 10, 20, 30 kilometers. Okay, so 3 boxes, every box is 10. The rise is actually 30 kilometers. Just be careful with that. And then what's 30 divided by 3? It is 10. So that's another way of getting the 10 kilometers per hour. All right. So look, you can do it either way. The question might ask for one way or the other sometimes, but it's just important in maths to be able to do things a couple of different ways sometimes, because we mightn't have all the information to do it a particular way. Okay. Just going to finish off with question 4 over here. So find the speeds of the 2 cars in the graph. Okay. So what I might do is I might do one of them using the formula and the other one using the slope. So for car 1, I'm going to do the formula. Speed is equal to distance over time. So car 1, total distance travelled is 180. So at the end of car 1's journey, it's gone 180 kilometers. How long did it take car 1 to do that? 3 hours. Okay, so that final point is 180 kilometers and 3 hours. So distance is 180, time is 3. 180 divided by 3 is 60 kilometers per hour. Okay, car 2 then. Now I just want you to think for a second, is this going to be faster or slower? And then I'll talk a little bit about that at the end. So is car 2 going to be faster or slower? So, as I said, I could do this the same way. I could do the formula if I want, but just so I'm doing it the 2 ways. I'm going to pick 2 points. I think this point here and this point here, or this. They kind of the only 3 points I'd pick on this journey. This one, or this one. You want to be picking points where kind of 2 grid lines meet. Is going to make your life easier. If you pick that point there, it's not really clear if that's like 2 2/3 hours, 2 3/4 hours, so it's a bad one to pick. So if I pick these 2 points here, so slope is rise over run. So between those two, the run I'll do first is 1, 2. Okay, and that's just 2 hours. So that's 2. So that's gone up in jumps of 1, so you don't need to worry about the run too much. That's 2. What's the rise then? So the rise is 1, 2, 3 boxes. Okay, the boxes here are going up in 20s. Okay, so it's 20, 40, 60, 80. So 3 boxes is 320. So that must be 60. Okay. So 60 divided by 2 then is 30 kilometers per hour. Okay, so car 2 was going slower than car 1, and the way you can tell that straight away from the graph you might have got it a second ago is that the slope is flatter. Okay, so car 1, the slope is steeper, so that means it's traveling at a higher speed. So on these distance time graphs, the steeper the line, the faster the car or whatever it is moving. Okay, so look, that's distance and time graphs. Okay, so it's a little bit of the coordinate geometry, the line we were doing before. It's a little bit of distance and time. Okay, so as I said, just be careful with them. So especially the distance, it will often, so if you look at this one, it's 180 kilometers, so you're never going to have 180 boxes in your copy. So if you were ever drawing this, you would also have to go up in jumps of 20 or jumps of 10 maybe. Okay, if you're going up in jumps like that, just be careful when you're getting the rise with the slope. Okay, but when you've got a distance and time graph like this, 2 main ways of getting the speed would be the formula. So just read off the graph, what's the total distance traveled divided then by the total or final time to travel that distance. Or you could also pick 2 points on the graph, get the slope, and that will give you the speed as well. Okay. Third way maybe you're getting the speed sometimes is if you've got a table like this and you can see every hour that passes how many extra kilometers are going. So here it was every 1 hour I was going 10 more kilometers. So that's just 10 kilometers per hour. Okay. But that is distance and time graphs.